All right. So when you connect these dots, it is a curve. These have come off of your unit circle, so you've like unwrapped the circle onto this graph. If you plotted all of those points in between, like if we plotted pi over 6 1/2, pi over 4 root 2 over 2, pi over 3 root 3 over 2, you'd get this curve happening with your graph. Those points are kind of a pain to plot, so we're not going to plot them. You just draw it with a curve. So here's what it should look like. Oof. I think yours prettier than mine at the end, okay? That is the general shape of your sine curve. It's going to keep going forever. This wave, this up and down is going to keep happening. We don't put arrows on the end though, because that kind of makes it look like it's just going up or down. So we're just like cutting off our viewing window and just looking at this section. But know that it will continue repeating forever and ever. Okay? And it'll always follow that pattern, you know, 0, -1, 0, +1, 0, -1, 0, +1. Anybody questions on the parent graph for sine? Okay. Anybody need more time on it? Okay. Let's look at cosine now. So again, guys, fill in, evaluate these cosine points, and then try to plot them for me, okay? I'll give you a minute.
Of having a negative cosine.
Negative angle means you travel backwards. So like on your circle, like if it said pi over 2, positive pi over 2, you'd go that far in that direction, right? No, positive pi over 2, you'd go here, right?
Yeah.
So negative pi over 2, you travel that same distance, go in the opposite direction. Just look at where you end up.
So if I had -3 pi over 2, yeah.
So positive 3 pi over 2 is going that far, right?
Because it's 3.
Okay, 2 steps here. Positive 3 pi over 2. Here, right? And you traveled this far to get there. So negative 3 pi over 2, you travel that same amount in the opposite direction. This is 3 pi over 2.
Yeah, so normally when I go over here, I go this way.
No, but you have to start at the same starting point. Here, let's label one. This would be negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. You're just traveling all of those routes. So negative 2 pi over 3. Oh, sorry, not that here. That's negative pi. Negative 5 pi over 4. Negative 4 pi over 3. That'd be negative 3 pi over 2. Over 6 and all the way back around. Does that make sense?
So it's just like a near circle flips.
Yeah, going backwards. Yeah, you can do so. All right, guys, let's go through these. Oh no, did we have trouble? All right, guys. That is what your cosine graph should look like. Anything you notice about the two graphs? The same but different. Okay, yes. How is it different?
Well, instead of crossing at 0, the origin is at 1.
Okay. So let's say, I know you guys can't do this on your paper. What if I took this graph and went like that? Ignore this part in the middle here. Do you see how it is the sine curve just shifted? Now I have two parts. Does that make sense? Okay. Fix my graph here. You don't have to write anything down for that. It's just recognizing they're very, very similar graphs. It's just a shift of where they start. So we'll spend a whole day graphing tangent and cotangent. We'll spend a whole day graphing secant and cosecant. Okay, don't worry. Today is just sine and cosine. Or which one? Kind of. They look like this.
Well, that makes sense.
Yeah, but that's not a today. All right, let's turn the page. Okay, so knowing those two parent graphs, the way you guys are going to graph everything is based on shifting and the transformations of those parent graphs. So just like you've done before, where you have like a vertical stretch or shrink, you have a vertical shift, you have a horizontal shift, and you can have a horizontal stretch or shrink. We are only going to deal with two of those today. We're only going to deal with the A and the D if you look at how this is written, just to make sure we've got the parent graph down and the basics of what we're doing. So this is, it can be with sine or cosine. These are the exact same thing, just depending on sine or cosine. That leading coefficient, it's called the amplitude now. It has a new name, but you know it as a vertical stretch or compression. We'll just write vertical stretch. That's the thing you multiply the y values by. Okay. You can make that as a note here too, if you can squeeze it in. Okay. All right, the period of your graph, that's talking about how long it takes for it to repeat. So if I go back to like my sine curve here, do you guys see how, like if I start at 0 here, 0 to 2 pi, do you see how that's like a full cycle of the graph and it would start repeating again after that? Does that make sense? That's what the period is talking about. How long does it take for one full cycle? Everything we are dealing with today, that's just going to be 2 pi. Okay, we're not going to change that today. Next class, we will deal with what happens when it changes. But today, it is just 2 pi for everything we're doing. Because our B value right now is always going to be 1. Phase shift, that's just the left or the right shift. It just has a new name. You treat it like you always have. If it says plus pi over 2, you go left pi over 2. Nothing too different there. And then the D at the end, that's no new name, no new anything. It's your vertical shift put down. This vertical shift will always equal what is called your midline. And I'll show you on the parent graph here where the midline is. The midline is exactly what it sounds like it is. It's the line in the middle. Like if I look at this sine graph, if I drew a line right on the x-axis, that is called your midline. And then if your graph shifted up or down, like if you look at it, right, if I move that up, do you guys see how the midline would follow? Okay, so the vertical shift is always just equal to whatever the midline is. Okay. All right, so let's graph a few of these. Okay, so without looking back at your parent graph, see if you can graph your sine parent graph. That was the first one you did. Think about where it started. What's the pattern? Try to just plot the points. Some of you are looking at me like, nope, there's nothing in my brain that's going to tell me how to do that. It's the one that started at 0, 0 in the center. I'll help you if you need it. Try first if you're feeling up for it. Oof. How'd we do? You can do it now that it's up here, yeah. Okay, so keep it, you've got the visual now of the parent graph of sine. Every time we graph, if you want to plot just the position of those parent graph dots, you can. So I'm going to do them in red. I'm just going to put them in their normal position. I'm not going to connect them. You want to get to the point where it's just like boom, 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 boom. Like it's just automatic. You know exactly where they go. That takes time, okay? But that's what we're shooting for. I'm going to use different colors on a lot of our graphs today. If you have different colored pens or pencils, now is a good time. I have some up front as well. Okay, so the second one, it says y equals negative sine of x. What does that negative do? Flips it. Yeah, it essentially multiplies your y values by a negative 1. Okay, so yes. The points that are at 0, are those going to go anywhere? The points that are like on the x-axis? No, they don't change because flipping them or multiplying by a negative doesn't really do anything. So I'm going to cover those up in green. The 2 points that are at positive 1, where are they going to go? Negative 1. And the points that are at negative 1, where are they going to go? Positive 1, okay. Okay, do we see it? Just flipped? Makes sense? Okay. All right, everybody okay with that one? Let's try 2 sine. And again, I'm going to put the red dots there. Parent graph dots. Some of you will get to the point where you're like, I don't need those. I can just multiply by 2. That's fine. I don't care. Do what works for you. So again, what am I doing in this graph with the 2 out in front? Multiply those y values by 2. It's just going to get taller because the zeros, again, won't change. If I multiply 1 by 2, I get 2. Negative 1 times 2 is negative 2. Everybody okay with the 2 sine of x? Okay, try the negative 3 sine of x. Look up here when you're ready. How we doing, guys? Okay. Just an a value, not too bad, right? We can do this. Okay, so now let's try a d value. We don't have any a values happening on these, just the d value, your vertical shift. So let's do the first one together. Y equals sine of x plus 2. So again, I'm going to put those parent graph dots in red. And now this time, what does the plus 2 at the end mean? We're just shifting everything up 2. So you're just going to go dot by dot and literally move it 1, 2, count up 2. And you can count and move every single dot. You can also, like if you start to see the pattern, you're like, oh, I know this is like the middle of the graph. I can just draw it from there. That is fine too. Hopefully yours is prettier than mine. Let's try it again. Okay, guys, I also asked domain and range. We can do these with interval notation. The domain every single time for sine and cosine, what do you think it's going to be? Negative infinity to positive infinity. It just keeps going forever. Nothing gets skipped. There's no asymptotes. There's no anythings. Domain is everything. If you're going to do that, you have to do proper notation. You'd have to do x such that x is an element of the reals. Okay, so that would be, it's squiggly brackets. What do you do? Okay, now the range, I'd recommend interval notation for this as well. The green graph at the end here, what is the lowest it goes? +1, right? And that's included, so you'd have a bracket. And then what's the highest it goes? 3. Okay, so not that painful on domain and range, right? All right, you guys try the next one for me. Y equals cosine of x minus 2. What's up? Still just up and down because it's outside of the x. If it had been like that, that would be a left and right shift. The only thing that's different is you start with the parent graph of cosine instead of the parent graph of sine. So guys, look back at the front page if you need to find your parent graph dots where they would go. It's the one that kind of looks like a W. Yeah. We'll wait. So guys, those red dots, those are my cosine parent graph dots. All right, guys, and then we're going to go down to the whole graph. Okay, and that's what it should look like at the end. Yay? You getting there? Domain and range. Domain, all real numbers, negative infinity to infinity. Your range this time is -3 to -1. All right, guys, questions so far? You doing okay? All right, when you're ready, turn the page. Anybody need more time on this? Okay. All right, couple things. Number one here, you can see we have an A and a D value. We have both things happening. Okay, so we have to do that. And also on my graph, I have these boxes here, okay? You have to label your x-axis. Today, it's always going to be the same labels, but we just need to get in the habit of labeling it. Next class, when we have a B value, when the period changes, those numbers are going to change. But for right now, it's going to be the labels you've been seeing along your x-axis the whole time. I know the boxes are small, so try to write nicely. That first one would be pi over 2, pi, 3 pi over 2, and 2 pi. It's just from your circle, like the y-axis, the x-axis, the y-axis, the x-axis, okay? Just working your way around. And then the left side is the exact same values except negative. Which again, I'm trying to squeeze in there. Make my marker skinnier. So, which order should we do them in? It's a good question. Amplitude and then shift. It's just like order of operations. We would multiply before we would add or subtract. Okay? So, we can still put our sine parent graph dots on here. Are you guys comfortable yet with we could multiply by 2 right from the start? Like, could you do that stretch? Or are you like, no, I want the parent graph dots, and then I want to multiply, and then shift? What do we think? Can we multiply right away? Yes? No? Okay, I'm seeing some no's. That's okay. All right, so let me put them on here. The negative ones kind of run into our labels. There's a dot there, I promise. So if you don't want to go through the boxes, like, let's see. I could make this 1, right? If you wanted to do that, but you're kind of going to run out of room because we're shifting down by 3. So I'm just going to end up with my dots in the boxes. That's okay. All right, let's do that stretch by 2 first. That's our amplitude. So I'm going to have green dots for this. All right, and then I need another color. We're going to go bright pink for my vertical shift. Do you guys see that we need to then shift down 3? All right, am I shifting the red or the green dots down 3? Green, yeah. We stretched. Now we're going to count down 3. 1, 2, 3. 1, 2. In the box. 3. 1, 2, 3. All right, let's pause there for a second. I know you can't read all my labels anymore, but... after stretch by 2. So yeah, take the green dots and move those down. 3. Yep. And doing those in the right order really does matter. If you shift down 3 first and then stretch by 2, you would have a very different graph than what we have, okay? Domain and range, domain all real numbers. Range, it looks like 1, 2, 3, 4, -5 to -1. If I asked you where's the midline on this graph, what would you tell me? -3, yep, okay. It's gonna be halfway in between. Okay.
So, the side midline equals -3.
It would be y equals -3. I think you have a delta math question or two that asked you to find that from the graph. And so it's y equals whatever that is. All right. You guys ready to try number 2 on your own? Or we need a sec here? I see some people still looking. Let's hold on. How we doing, Chandler? Jude, what's wrong?
Oh, no, no.
Sure.
Yeah.
All right, guys, try number 2. Now, tricky part here when labeling the amplitude, you definitely have a flip happening, right? Like that little negative means flip. But what is the amplitude actually? Look back here. Do you see how amplitude was absolute value of A? It's just 1. Okay. All right, I'll give you guys a second to try. So you can still multiply the y values by like negative whatever the number is, but if I'm actually asking you the amplitude, it technically is just the positive, because it's the distance from the midline to the top. So what does that negative tell you to do? Mm-hmm. You still multiply the y values by -1. It's just not called, when it's amplitude, it's just I know. You can see why we spend a couple days on this, right? Like there's a lot of details. Which one's the second one? So you flip. Yeah, that looks good. Sure. So that's your
Oh,
okay.
so yeah,
So
this
what
is
is
this was what we said. Yeah, these are the straight.
I should take that.
Yeah, it's gonna say that. And in this case, oh yeah.
Okay. That. Now shift your so that's
So you still do opposite, you just try it. Yes. For here, I choose my legs. Why here it's opposite here?
so when you, the word amplitude, because I asked you what the amplitude is, it's always positive. But what you're actually graphing is what occurs as an equation. Once it clicks, it's like, oh, I know these dots.
Yeah.
It just takes a little time to like know where you're starting from. Okay. Yeah, if you're gonna do all the different dots, you definitely need different colors. If it's all in pencil, yeah, I don't know. Good luck. I need to label. And guys, I know it's tedious to label all these little things, and you're like, it's the same labels every time. I know. You have to label them. Get in the habit of it. It's going to matter when we start changing the b value. All right, so I'm going to flip first. That -1 out in front. Okay, and then my final step, I need to go up 1. So the green dots are moving up 1. How we do? Walking around, it looked like a lot of you got there. So let me leave it up there for a second. Domain. Green. Move it up a little. All right, guys. Questions on that one? Okay, and guys, I don't like number 3 with the 1/2. It just gets so, like, so smushed that you either need to relabel your y-axis or not. Skip number 3. Let's go down to number 4. If you already did number 3, good job. I'm sure you're fine. Go to number 4. Anybody questions on 2, though, before I scroll down? Okay. So again, ignore number 3. Just go all the way to number 4. Guys, are you getting better at the parent graph dots? Like, is the pattern, we're getting a little more, I don't know, fluent with that? Okay. First thing I have to do, multiply those y values by 3. When you're ready, guys, take a look. Questions, guys? for cosine? Did you do it as sine? Okay, let me look at yours and see if it's right. You just prefer the sine graph, cosine graph.
I just assumed they were all sine.
When you're ready, guys, do number 5. What's happening?
Oh my gosh,
For the last one? That's right. Yeah. That makes sense to me. I'll do it up here in a second.
like basketball, we started to like so like oh yeah. So do you guys do that? Because my dad my dad was I studied last year. I never saw that. My mom's too orange. Yeah, my dad was like
Oh, it's senior year. Our senior year. Yeah, I know. Our senior. Our senior. I'm doing it pretty well.
Well, okay, that's yeah,
That's why the butler.
it seems like it's a guy. One's a guy.
No, the guy that's not outside. That's Alex.
is it 4 or negative 4?
I think it's -4. So, okay. The vertical stretch, like all of that, you multiply by a -4. Amplitude, though, is absolute value, okay?
Oh, okay, so it can't be negative.
Yes. But you still, the negative still matters for graphing. Yeah, like you still flip it, all of that. It's just when you write it, you write +4. Okay?
So when you're graphing it, you graph it as positive?
Yeah.
Like when you say the amplitude.
Like if I ask you, what is the amplitude? Always positive. Yep. All right, guys, let's take a look at number 5 here. I know it's tricky. Asking you the amplitude and what you actually do on the graph sometimes don't match. Okay, amplitude has to be positive because it's the absolute value. But on your graph, you are actually multiplying y values by -4. Make yourself a note if you need to. Multiply y values by -4. But the technical definition of amplitude is absolute value of a. Okay. Let's see, domain and range, -infinity to infinity, -2 to 6. All right, guys, how we doing? Great, we're getting it. Baby steps, right? One step at a time. Guys, we're gonna do just a couple more, and then I'm gonna give you some time to work on your homework, just because your homework's on Delta Math, and I want to make sure you if you have questions on how it's asking anything. Let's do, turn the page. Let's only I went too far. There we go. Let's do number 2. I guess we'll do just 1 and 2. So you get a sine and a cosine, okay? 1 and 2. So one of them is a sine, one is a cosine. Take a few minutes here, try both of these, and then we'll be done with notes, okay? You're not really awake yet. It feels like a Monday too, and it's not. I know.
Oh, wait, no. The difference is that but it's still sine. We have the same answer.
I need to open it for you on Delta Math. Give me 1 second here. All right, guys, check those. How'd we do? Going pretty well? Okay, let me get your Delta Math open. All right, guys, anybody questions on these two? I'll leave them up there.